Hello and welcome to my video on related rates, finding rates of change by relating something that is known to something that is unknown. So what is a rate of change? Simply put, a rate of change is how something changes in relation to something else, generally how things change with respect to time. If we look at the picture below, we can see an example of a rate of change. After each interval, the barrel is filled with more water. But how do we determine this rate of change? We can do this by finding a related rate, as shown in the example that follows. Let's look at the water barrel. Suppose you have a 4-foot tall water barrel with a diameter of 2.5 feet and is filled with water at a constant rate of 3 feet cubed per minute. Now we need to determine the rate in which the water rises when the water level of the barrel is half full. To find the rate of change, we can look at each of the 7 steps. We can draw a sketch or a picture of the situation, assign variables, determine what we know and what we don't know, find an equation that relates to the variables, and use the differentiation of the equation, usually with respect to t, to find the unknown rate of change. Looking at the first example of the water barrel and examining what we've been told in the question, we can draw a picture of what's going on, like this. We have a barrel that is 4 feet tall, with a 2.5 foot diameter, that is filled to the H level with water. Now, since we had already seen in the question that it said the barrel was half full, we know that this water level will be at 2 feet. Now we assign our variables. Since we're working with something like this barrel, we know that we're looking for volume. So we'll assign V for volume, H for the height of the water, and T for time. We'll do it in minutes. So now we need to determine what is known and what is unknown, or what we're trying to find. We know that the change in volume over time is 3 feet cubed a minute, represented by dV over dt equals 3 feet cubed per minute. What we are trying to find is the change in water at the height that is asked based on the time, or dH dt. Now we find an equation that relates these variables. And since the barrel is a cylinder shape, we will use volume, or the height times pi times the radius squared. Since we're using 3.14 as a representation for pi for the ease of this example, we'll plug that number in. And we'll multiply it by the radius squared, or 1.25 squared, which is half the distance of the diameter. This gives us the height times approximately 4.9 will give us the volume. Our next step is to differentiate the equation with respect to time, or t. To do this, we take our known part of the equation, that the volume equals the height times the approximation of 4.9, and then we look at it with respect to what we know. Since we're looking to find the change in water level at the height halfway up the barrel, or 2 feet, we are looking at 2 times the change in volume over time times the differentiation of our equation. Now we substitute in our known values. We know that the change in volume over time is 3 feet cubed per minute. And now we can solve for our unknown rate, or our h, as respect to t. So we find that our change in height over time is 6 divided by 4.9 feet a minute. Now we use the known rate to find the unknown rate. Or 6 divided by our approximation gives us approximately 1.22 feet per minute. So with looking at the respective volume over time, we have found that the water in our barrel at 2 feet will be increasing by 1.22 feet per minute. Let's look at another example, or a ladder. A 13-foot tall ladder is resting against a wall, and the bottom of the ladder begins to slide away from the wall at 2.5 feet a second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet away from the wall? Following our previous steps, we can draw or sketch a picture of the situation. Here we know that the ladder is y feet up the wall, and it is sliding out at a base of x at 2 feet per second. Now we assign variables. Let's use x for the distance from the bottom of the ladder to the wall, y for the distance from the top of the ladder to the ground, and t for time in seconds. Now let's determine our known and our unknown. We know that our change in x with respect to t is 2 feet per second, and we're looking for the change in y with respect to t when t equals 2. We found this out because the ladder is moving out at 2.5 feet per second. So it will hit 5 feet at 2 seconds, or t equals 2. Now we need to find an equation that relates these variables. Since we're working with a triangle, we can use the Pythagorean theorem. We also know that x squared plus y squared equals 13 squared, which was the length of our ladder. Now let's differentiate the equation with respect to time. First, let's find the x and y values. Since we know from the Pythagorean theorem that our x squared plus our y squared will equal 13 squared, and we know that we're looking at our ladder when it is 5 feet away from the wall, we can use these values to determine our y value, which would be 12. Here we can see our picture with our new representations. So now we're differentiating the equation with respect to t. We know that 2x times the change in x over t plus 2y times the change in y over t equals 0. Let's divide by 2 to get rid of that. And now we've got x times the change in x over t plus y times the change in y over t equals 0. We substitute in our known values, or 5 times the change in x over t, or 2, plus 12 times the change in y over t. And we solve for our change in y over our change in t. 10 plus 12 equals 0. 12 equals 12 times dy dt equals negative 10. So our change in y over our change to t is a negative 10/12. So we use our known rate to find our unknown rate. The change in y divided by the change in t equals negative 10/12, or approximately negative 0.83 feet per second. The top of the ladder is sliding down the wall at approximately 0.83 feet per second when the bottom of the ladder is 5 feet from the wall. Thank you for watching. If you have any questions or comments, please feel free to leave them in the comment section below. Thank you.